Winter makes your house tell on itself. Uneven snow melt on a roof. Frost patterns that don't line up. Ice forming at the edges. Condensation collecting on glass. These aren't random events. They're patterns. And they tend to show up when temperatures drop quickly, and the difference between inside and outside becomes extreme. That's when the house is under the most stress, and when small weaknesses become visible. Winter doesn't create problems. It magnifies the ones that were already there. When outdoor temperatures fall, the temperature difference across the enclosure increases. That difference drives heat outward. The larger the gap between inside and outside, the faster heat moves. If insulation is inconsistent, those areas lose heat faster. If air moves through small gaps, that heat moves even faster. The result isn't immediate failure. It's imbalance. Certain surfaces cool more quickly. Certain sections of roof warm more unevenly. Certain rooms require longer heating runtime. Winter simply increases the pressure on the system. Pressure differences increase in cold weather as well. Warm indoor air rises, cold outdoor air is denser. That stack effect pulls air upward and outward through the building. If the enclosure isn't continuous, air finds pathways. And when air moves, moisture moves with it. That movement doesn't always show up immediately, but under winter conditions, those pathways become easier to detect. Drafts feel sharper. Edges feel colder. Moisture appears where surfaces cool fastest. The house reacts to the stress. Drying potential also changes in winter. Cold air holds less moisture. Sun exposure is limited. Ventilation patterns shift. So when surfaces get wet, from air movement or condensation, they may dry more slowly than they would in warmer months. Repeated wetting plus reduced drying is what creates material risk over time. Not a single event, not one cold night, but a pattern under stress. Winter shortens the margin for error. Take ice dams as an example. They don't form because snow exists. They form because some roof areas are warmer than others. Heat escaping unevenly melts snow in one place while surrounding sections remain frozen. Water refreezes at colder edges. The ice is the visible result. The real story is temperature imbalance across the assembly. The same is true for condensation. The surface that cools first shows the signal first. Mold, when it appears, follows the same logic. It isn't spontaneous. It's a biological response to repeated moisture exposure combined with limited drying. Under winter stress, surfaces may cross the threshold where moisture lingers longer than intended. That doesn't mean catastrophe. It means conditions aligned. Understanding that sequence removes drama from the conversation. It becomes predictable, and predictability is useful. Energy use often reflects the same stress patterns. Longer heating runtime. Uneven temperatures between rooms. Systems compensating for localized loss. The equipment isn't necessarily failing. It's responding. When the enclosure loses heat unevenly, the mechanical system works harder to maintain balance. Winter makes those imbalances easier to feel and easier to measure. Again, not a new problem. A magnified one. When winter makes something visible, it's showing you where the building is under stress. Snowmelt patterns, frost lines, condensation, ice at the edges. These are signals. Over the next few weeks, we're going to look more closely at what those stress patterns actually mean and how to read them without overreacting. Because winter doesn't create problems. It reveals how your house works. Passive house for the people.